press the bell icon on the YouTube app and never miss another update.
Hello students, welcome to the part 5 of the chapter sequences and series. In the last session we were talking about some problems from the exercise 9.2. So now let's continue the same. Now let's complete that exercise 9.2. Okay, so now let me move to another question, that is okay, 11th question, that is 11th question. Sum of the first P comma Q and R, P, Q and R terms of an AP, or A comma B and C respectively. Prove that A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q equal to 0. Now this is a question, students. Question is, sum of the first P terms and Q terms and R terms given. Sum of first P terms, in the sense sum of first n terms, that is what n by 2 into 2a plus n minus 1 to be like that. Sum of first P terms is given, that is equal to a, and sum of first Q terms given, that is equal to P, and sum of first R terms is given, that is equal to C. That's what has been given. Now we have to prove. So the sum of these three terms is equal to 0. Okay, simple one, right? Okay, now let's write the data given. Sum of first P terms of an AP. Yes. So sum of first P terms becomes what? N by 2. You mean in place of n, you have to take P by 2 into 2a plus n minus 1. You mean P minus 1 into D, where A and D are what? A is the first term of the AP, D is the common difference. That is equal to A. This is given. Or you can write this as okay, let it be. Or you can write okay, let it be. So this is what equation 1. Second one, or you can write this as 2a plus P minus 1 into D is equal to 2a by P. Taken this P by 2 right side. Take it as equation 1 now. Okay. This is what using sum of first P terms of an AP, that is equal to A. Now second thing, sum of first Q terms. So Q by 2. So 2a plus Q minus 1 into D, where A and D are first term and the common difference respectively. This is given, that is what B. Sum of first Q terms is given, that is B. So or I can rewrite this as what? 2a plus Q minus 1 into D is equal to 2b by Q. Take it as equation 2. Okay. Third thing, that is what? Sum of first R terms, that is what? R by 2 into 2a plus R minus 1 into D, that is equal to C. Or this is same as 2a plus R minus 1 into D is equal to 2C by R. This is equation 3. Very simple, student, just solve equation 1 and 2, you get the answer. So let me find 1 minus 2. 1 minus 2 gives what? 1 minus 2 gives, I mean subtracting equation 2 from 1. So equation 2 from 1. So now 2a 2a get cancelled, right? 1 minus 2. So 2a get cancelled. So now p minus 1 into d minus q minus 1 into d. So I'm going to take d outside. D into p minus 1 minus of q minus 1. This is what LHS. Right. Now here 2a by p minus 2a by p minus 2b by q. Okay. On simplification, you get here. 1 get cancelled, right? Minus 1 minus of minus 1 plus 1. 1 get cancelled. You get d into p minus q equal to, right? Here what do you get? PQ LCM, right? So 2AQ minus 2BP. Okay. So or from this you get what? D is equal to, so D is equal to 2AQ minus 2BP whole divided by PQ into P minus Q. Take it as equation 5. So this is by equations 1 and 2. I mean 1 minus 2 gives D. Okay, now in the same way, let me find 2 minus 3. So 2 minus 3 gives now 2 minus 3 gives what? In the same way, same. So 2a get cancelled. So this minus this. So let me take D outside. D into, yes, q minus 1 minus of r minus 1. Q minus 1 minus of r minus 1 equal to 2b by q minus 2c by r. Okay. Here again minus 1 plus 1 get cancelled, right? Minus 1 plus 1 get cancelled. So what do you get remained? So d into q minus r equal to, yes, qr is the LCM. You get 2br minus 2cq. Or from this you will get d is equal to 2br minus 2cq by qr into q minus r. Equation 6. Now let me equate equation 5 and 6, you get the answer. Okay. Okay, now so I am going to rub this. Yes, now you get. Since we have the same value of d in both equation 5 and 6, so I am equating those. I mean LHS are same, so RHS must be same. I am going to equate equation 5 and 6 from 5 and 6. We have 2AQ minus 2BP divided by PQ into P minus Q equal to, so 2 times of BR minus 2 times of CQ divided by QR minus Q minus R. Okay, this is from equation 5 and 6. Now on both sides I am going to take 2 outside and 2 get cancelled, right? Right? 2 get cancelled on both sides. Now Q also get cancelled. 2 and Q get cancelled on both sides. Now let me cross multiply. So here 2 is 2 get cancelled. You get what? AQ and BP, BR and CQ remain. Let me cross multiply. So AQ into this. So you get AQR into Q minus R. Next, minus BP into this. So minus BPR into Q minus R equal to, so P into P minus Q into this BR. Here 2 get cancelled. No, already cancelled this. So BR into this. So you get BRP into P minus Q and CQ into this. So minus CPQ into P minus Q. Okay. Now let me divide by. So dividing by PQR on both sides. I am going to divide all the terms by PQR. So what happens here? PQR, here QR get cancelled, remaining is A by P into Q minus R minus PQR, so PR get cancelled, so B by what? Q into Q minus R equal to BRP. So R and P get cancelled, so remaining thing is B by Q into P minus Q minus PQ get cancelled, C by Q into P minus Q. Okay, so now, so A by P into Q minus R minus, so B by Q, so B by Q is Q minus R into, here also we have B by Q. Let me take to the left side. Yes, you get what? This becomes minus, you mean minus P plus Q, right? Sorry. So here I am taking Q minus R outside, sorry, B by Q outside, and taking this left side becomes minus B by Q. So minus B by Q taken outside. Okay, so remaining is what? Plus P minus Q, right? Hope you got this. If I taken this outside, it becomes, I mean, if I taken this left side, it becomes minus B by Q. So minus B by Q taken outside, so remaining thing is plus of B minus Q. Plus into minus, you get again minus. Okay. Plus C by Q into P minus Q equal to 0. So now QQ get cancelled. So now the answer is, I mean, you got the answer, that is what? A by P into Q minus R. Here we have minus of this, no? So instead of P minus R, I am going to take minus sign outside, it becomes R minus P. So plus, then plus B by Q into R minus P, right? Plus C by R, right? C by Q I have written, right? C by R. So here R, sorry, dividing by PQR, no? So PQ by R, right? So C by R into P minus Q. This is your required answer. Hence, proved. Hope you got this. Here divided PQR, no? Divided by PQR. So PQ can cancel. C by R remained. C by R remained. So this is how the proof: A by P into Q minus R plus B by Q into R minus P plus C by R into P minus P. Very simple. By using the data, sum of first P terms given A, sum of first Q terms given B, sum of first R terms given C. Take it as equation 1 and 2 and 3 and solve those two. I mean, solve those three equations, 1 minus 2 and 2 minus 3. You get the values of D. Both are same, no? I mean, both are equal to D, no? So I can equate these two. On equating these two, you get the answer, required answer. So this is about 11th one. Okay, now let us move to one more question, that is 12th one. The ratio of the sum of m and n terms. The ratio of the sum of m and n terms. Ratio of the sum of m and n terms of an AP is m square is to n square. Show that the ratio of mth and nth terms. The ratio of mth and nth term is 2m minus 1 is to 2n minus 1. The question is the ratio of the sum of m and n terms are the of an AP or in the ratio m square is to n square. So given what sum of m terms divided by sum of n terms, this is given m square by n square. This is what given. Using this, you to find the ratio of mth and nth term. You mean you have to find, yes, a plus mth term is what? M minus 1 into d divided by a plus n minus 1 into d. This is to be found. Now, what is this? What is this equal to? Sorry, we have to prove this. We have to prove a plus m minus 1 into d equal to a plus n minus 1 into d is equal to 2m minus 1 divided by 2n minus n for m and n number of terms. Okay. We have to prove that. Simple as before. In the last session, we were discussing the same type of problem, that is what finding the ratio of 18th terms, right? 18th terms of 2 AP arithmetic progressions, right? Same as before. Same type of work. So now sum of m terms is what actually? So m by 2 into 2a plus m minus 1 into d, right? For a is the first term, d is the common difference, divided by n by 2 into 2a plus n minus 1 into d. This is given. This is equal to m square by n square. So here 1 by 2 get cancelled and m get cancelled, so n get cancelled. So what is remained? So remaining thing is 2a plus m minus 1 into d divided by 2a plus n minus 1 into d. This is equal to m by n. This is remained now. 1 by 2 get cancelled. So here m get cancelled, n get cancelled. Remaining thing is this is equal to m by n. Now you to make this, you mean in this place you to get this. You have to get this. That's it. That's the thing here we have. In place of 2a plus m minus 1 into d, you to get a plus m minus 1 into d. In place of 2a plus n minus 1 d, you to get a plus n minus 1 d. In place of m, you to get this. In place of n, you to get this. That's it. For any numbers m, if it is true for m number of terms and n number of terms, it must be true for some any other number of terms also. You mean if it is true for m and n number of terms, it should be true for 2m minus 1 number of terms and also 2n minus 1 number of terms. I mean I am going to replace m by 2m minus 1, n by 2n minus 1. That's it. Because m is some number, n is also some number. If it is true for m number and n number of terms, it must be true for 2m minus 1 and 2n minus 1 terms also. So I am going to replacing m by 2m minus 1 and n by 2n minus 1. That's it. So what do you get? Here 2a plus m minus 1. So I am replacing m by 2m minus 1. So in place of m, 2m minus 1 into d whole divided by, hope you are getting this, 2a plus, right, n. In place of n, I am going to replace n by 2n minus 1. So 2n minus 1 minus 1. 2n minus 1 minus 1 into d is equal to, yes, again in place of m, 2m minus 1, in place of n, 2n minus 1. Okay, now you get what? 2a plus 2m minus 2 into d, 2a plus 2n minus 2 into d, that is equal to 2m minus 1 by 2n minus 1. So let us take 2 outside from the numerator and also from the denominator, get cancelled. 2 to get cancelled, what is remained? This gives a plus m minus 1 into d divided by a plus n minus 1 into d. This gives 2m minus 1 by 2 minus 1. That's hence proved. Hence prove this. That's it. Okay. Let's move on to question number 17. Question is like this, a simple one. A man starts repaying a loan. A man starts repaying a loan. Repaying a loan as first installment. First installment of rupees 100. First installment of rupees 100. If he increases the installment by rupees 5 every month, what amount he will pay? What amount he will pay? He will pay in the 30th installment. In the 30th installment. A simple one. It's like an EMI, right? EMI for a loan, maybe any, personal loan, whatever, taken in a bank. He is repaying a loan amount in terms of installments, monthly installments. He is paying, he has paid rupees 100 in the first month, and he has decided to increase the amount by 5 rupees in the next month. You mean, if he pay rupees 100 in the first month, then he will pay rupees 105 in the next installment, and plus 5. In the third month he is going to pay 110 rupees. In the fourth month 115. In this way, in every month he will increase loan amount, installment by rupees 5. Then if he increase like this, if he increase loan amount, installment by rupees 5 every month, what will be the installment in the 30th month? That's the question. It's very simple. Of course, this is related to AP sequence. You mean a difference between the consecutive terms is equal to same, that is what 5. So, from the data, the installments are what? First installment is 100, next is 105, next is 110, next is 115 and so on. Okay, then what about the 30th installment? Okay, let me take this is the first term. So here or you write like this, form an AP, right? Now here we have A is equal to 100. So D is 5, right? Common difference is 5. So one thing you observe, if first term is A, second term is what? A plus D, you mean 100 plus 5. Third term becomes A plus 2D. So observe here, this is 100 is what? 100 is what? A. 105 is what? A plus D. You mean this is the first term, this is second term, A plus 2D. So A plus D. A plus D I can write as 2 minus 1 into D. So second installment I can write as A plus 2 minus into D. So second installment, right? This is the first installment. This is second one. In case of second installment, the amount will be what? A plus D, you mean A plus 2 minus 1 to D. In the same way, third installment will be what? 110. This means what? A plus 2D, right? In the same way, so this gives what? A plus 3 minus 1 into D. So this is what third installment. In the same way, his 30th installment will be, therefore, his 30th installment is equal to A plus 30 minus 1 into D, right? Okay. So what is A? 100 plus 29 into 5. So 100 plus, so 14. So that is equal to 245. This is what he has to pay in the 13th month. Okay, the installment, the installment amount he has to pay in the 13th month is 245 rupees. Rupees 245. Last week, right? Therefore, a man must pay rupees 245 in the 30th month. That's it. So these are the application, students. These are the applications of that we what AP. Sequences, right? Okay. Now let's look at the last question of this exercise. The difference between any two consecutive interior angles of a polygon. The difference between any two consecutive interior angles. Consecutive interior angles of a polygon is 5 degree. If the smallest angle is 120 degree, if the smallest angle is 120 degree, find the number of the sides of the polygon. Number of sides of the polygon, right? So, of course, by looking at the data you can see all angles of this polygon are in AP sequence, because they have given the difference difference between any two consecutive interior angles is 5 degree. In the sense, all interior angles of this polygon are in AP sequence, right? Okay, and first angle is given. The smallest angle is 120 degree. Let me take this as the first angle, that is what A is equal to 120 degree. Then what will be the number of sides of the polygon? Okay, so now solution. From the data, all interior angles form an AP series, an AP archentric sequence. And A is 120 degree, and let me take first angle is smallest angle is 120 degree, and A is what? 5 degree. You have to find N. Okay, N is what? Okay, now let us use the concept. Yes, we know that sum of all interior angles of a polygon with n sides. Sum of all interior angles of a polygon with the n sides is 118 degree into n minus 2. This gives what? Sum of all interior angles of a polygon with n sides, where n is what? Number of sides. Okay, now here anyway all interior angles of a polygon form AP sequence, so that for n number of sides or for n number of angles, sum of all angles, in the sense sum of n terms of AP sequence, nothing but what? N by 2 into 2a plus n minus 1 to d. This gives what? Sum of all interior angles, because they form an AP sequence, no? So this gives what? Sum of all interior angles, sum of all n interior angles, right? N number of interior angles equal to S n minus 2. I am equating these two. So this gives what? Sum of all interior angles, n interior angles, that is equal to what? Sum of all interior angles of polygon with a number of sides. That should be equal. Okay. Hope you got this right. Since it is an AP, since all interior angles of a polygon form an AP, therefore this gives what? Sum of all n interior angles, that is equal to 180 degree minus 180 degree into n minus 2. Let me simplify this, you get the value of n. Okay, now, so n into this 2an plus n square d minus n d is equal to 2 into this 360 into or 360n minus, so 360 into 2, 720. Okay, now yes, A has been given, that is 120 degree, and D is what we have 50. So 2 into 120 into n must be found, plus n square into 5 is D is 5 minus n, or before that okay, 5d, so this is D is 5 now, so n square 5n square minus 5n equal to 360 into n minus 720. So to get now 5n square 5n square 120, so 240n minus 5n, so 235n, 360 minus 235n minus 235, so you get, so 125n, so minus 125n, so, and plus 720 equal to 0. Okay. Dividing by 5 you get what? N square minus 25n plus 5 ones are 5 fours are, so 4, so 144, right? So n square is it right? Yes, 144. Next 25. Anyway, we have got this what? A quadratic equation. Let me simplify that. Let me find the value of n. So you get what? 144. I can write as 144. Is it right? 5 ones are. So again 144, right? So 144, so 12, yes, 12 into 12, or you can write, yes, yes, 16 nines, right? Yes, 16 nines. So you can write n square minus 16n minus 9n plus 144 equal to 0. So 9 into n minus 16 minus 9 into, so n minus 16 equal to 0. This gives n minus 16 into n minus 9 equal to 0. So this gives n is equal to 9 or 16. So a polygon having n sides, I mean 9 sides or 16 sides. For a polygon of n sides or 9 sides or 16 sides, all interior angles form an AP with common difference 5 degree, and with the first angle is 120 degree. Once again, a polygon with 9 sides or 16 sides, 9 sides or 16 sides, all interior angles form an AP with common difference 5 degree, and first angle is 120 degree. Okay, this is what the required answer. We got this. N is 9 or 16. Okay, this completes arithmetic progression. You mean arithmetic sequence. Hope you learned well, students. What is arithmetic sequence, right? So now let me move on to the second important sequence, that is what? Geometrical sequence or geometrical progression. Now we call as geometric progression. So geometric progression. Okay, let me define this first. Geometric progression. Or simply we write this one as GP. So geometric progression, we abbreviate it as GP or geometric sequence. Same as before, geometric sequence is sequence in which the ratio of the current term and the preceding term is same, and the constant, that constant we call as common ratio. Once again, geometric progression is a sequence of numbers, in which the ratio So in case of arithmetic progression, we have taken the difference. Right? Here the ratio. Here the ratio of the current term and the preceding term is constant and is called common ratio, the common ratio. Or we can also define as like this. GP sequence or GP progression is a sequence of numbers in which the ratio of the consecutive numbers is same or constant, that is called as common ratio. Okay. For example, I am going to take an example. Yes, a sequence with the first number, with the first term should be non-zero. 2, 4, 8, 16, 32, and so on. So this is the best example for geometric progression, right? So for example, here if I take first term a as 2, right? This is a1, a2 as 4, a3 as 8, and so on. So the ratio of a term and its preceding term, you mean a2 by a1, that is equal to a3 by a2, that must be equal to a4 by a3, that must be equal to an by an minus 1 should be same, and that we are going to take it as common ratio, and it is denoted by R. See, 4 by 2, 2, 8 by 4, 2, 16 by 8, 2, 32 by 16, 2, and so on. So this is best example for the common ratio. And one thing you observe, GP sequence is a sequence in which succeeding term can be got by multiplying a number or current term by R. You mean this can be got by multiplying R, this can be got, succeeding term can be got, succeeding of this can be got by multiplying R with this number. So what is R in this case? So 4 by 2 or 8 by 4, that is what? That is what R. See, to get this succeeding term, you mean to get the 4, the second term, you have to multiply 2 with the 2. In the same way, to get 8, you have to multiply 4 with 2. You mean R into this. R into this gives this. R into this gives this. R into this gives next term. You mean 32 2s, you mean 64 is the next term, and so on. And to get the preceding term, what to do? To get the preceding term of this, you need to get the preceding term of this, you mean this, you have to divide by R. So 8 by R, 8 by 2 gives 4. Once again, in general, to get the succeeding term an plus 1, you have to multiply a current term with R. Most important result. To get the preceding term, you mean to get n minus 1, you have to divide a current term by R. Hope you got this. These are the important results. To get the succeeding term, you have to multiply a current term by R, and to get the preceding term, you have to divide R to the current term. That's very important. This is what an plus is equal to an into R, an minus 1 is equal to an by R. This is to get the succeeding term, this is to get the preceding term, and an by an minus 1 is always is equal to R. Okay. So this is the result. An by an minus 1 is equal to R, that is our common ratio, and hence the general form of AP is given by, suppose if we take A as first term and R as common ratio, A as first term and R as common ratio, second term becomes what? A into R. As I told you now, to get the succeeding term, you have to multiply R with the current term. So next term again into R, you get AR square. Next term again into R, you get AR cube. Next term again into R, and so on. And nth term will be equal to A into R power of n minus 1, because This is A, you mean AR into 1 minus 1, first term. First term can be written as A into R power of 1 minus 1. Even 1 minus 1 is 0, AR power of 0 is, sorry, R power of 0 is 1. Second term I can write as A into R power of 2 minus 1. Yeah. Third term is what? A into R power of 3 minus 1. That is what? AR square. Fourth term is what? AR power of 4 minus 1. That is what? AR cube. In the same way, nth term is A into R power of n minus 1. This is nth term. So, nth term of the sequence is given by an is equal to A into R power of n minus 1, where n is the number of terms in the given GP sequence. Hope you got this, students. GP sequence or geometric progression is a sequence of numbers in which the ratio of the current term and the preceding term is always constant, and it is called as common ratio. Or in other words, geometric progression is a sequence in which the ratio of any two consecutive terms, is same and it is constant, is called as common ratio, and it is denoted by R. And from the definitions, we can easily say, to get the succeeding term of a given sequence, of a given GP sequence, you have to multiply with common ratio R. To get the preceding term, you have to divide the current term by R. So, and A must be, first term should be non-zero number. Okay, this is about geometric progression or GP sequence. And the common, as general form of GP sequence is what? A. If I take A as first term, A is a non-zero number, A as a first term, AR becomes second, AR square, third term, AR cube, fourth term, and so on, and the nth term is what? AR power of n minus 1. Okay, so this is an important result. Yes, geometric progression is a sequence of numbers in which the ratio of consecutive terms is constant, and it is called as common ratio, and is denoted by R. Okay, this is about geometric progression. Now let me discuss. Yes, hope you got this. Yes, once again, the general form, the terms, the first term is, if A is a non-zero number, first term is A, if it may be negative or positive, whatever. Second term becomes AR square, AR. Third term becomes AR square. Fourth term becomes AR cube. Fifth term becomes AR power of 4, and so on. Nth term becomes AR power of n minus 1. And the general form is what? An is equal to, yes, we have A into R power of n minus 1. To get the succeeding term, an plus 1, you have to multiply a current term with R. To get the preceding term, an minus 1, you have to divide current term by R. So these are the results, and from the definition, n divided by n minus 1 is equal to R, common ratio. Okay, this is an important thing. Okay, students, this is about definition of geometric progression. So, in the next class, in the next class, let me discuss how to find sum of n terms of a GP, and how to find sum of infinite number of terms of a GP, and geometric mean, and about exercise 9. Okay, let me continue in the next class. Thank you.